All right, thank you so much for joining us for our public meeting about this regional flood resilience project. My name is Christine. I'm an environmental planner with the Naugatuck+Valley Council of Governments. I'm joined by our project manager, Craig Stevenson. We have our representatives from Luke's Engineering, Ron and Terry. We have Alex from Save the Sound and our community liaison, Jeff. I'm hoping everybody online can hear us okay. If someone could give a little thumbs up emoji or something. But we'll get started. I'll just start with a very brief introduction. So this project is funded through the Connecticut DEEP Climate Resilience Fund. We, as the Naugatuck+Valley Council of Governments, your regional government, we received a grant to do some design work for a number of areas, culverts and drainage areas that have been identified as experiencing chronic flooding throughout the region. These were identified in a natural hazard mitigation plan we made for the region. And so we worked closely with the towns, with 9 of our towns, including, of course, Ansonia and Shelton, who we're talking about tonight. Bundled all those projects together. We did a single bid and procurement, and Luke's Engineering and Save the Sound have worked to design solutions for these aging, undersized culverts and drainage areas. So next slide, please. So our first round of public meetings was in December, and I do definitely remember one person who was there with us in December. Thanks for joining us again. And we took some input from the public at that time. At this point, we are sharing our deliverables with you. So what we're looking at tonight are 30% designs for each of the sites. There's a report that we'll reference that has a whole bunch of background information as to how they reach these conclusions, things like the hydraulic analysis, cost estimates, everything that went into the designs. And then we also have a grant funding guide because we're still in the planning phase and we want to help everybody get over the hump to the implementation phase and access some of the maybe the federal funding that's out there. So one more slide, please. And just to make sure everyone's in the right place at the right time, we're starting with the Ansonia project. This is a culvert in the Prindle Avenue, Doyle Drive, and Benz Street area behind Nelligan Field. And then at 6:30, we'll transition over to Shelton's project, which is in the Oak Avenue, Congress Street, Union Street, and Center Street area. So with that, I'll turn it over to Alex.
We want to skip over a slide or two. That was from the previous thing. Sharing the community design space. Okay, that's shown. All right. Thank you, Christine.
Were you going to start with Shelton or Ansonia?
Oh, we're supposed to start with Ansonia. I'm sorry. Skip through the start of the Ansonia. There we go. Good evening. My name is Terry Gallagher. I'm an engineer with Luke's Engineers, along with Ron Nault here in our team. The Ansonia project is located along Whitemare Brook on the east side of town along Prindle Avenue and Doyle Drive. And it is a watershed that floods on the upstream side of Doyle Drive. And it has a culvert that goes underneath the ball fields at Nelligan Field, Nelligan Park, that is undersized and doesn't have capacity for a 100-year storm. So it backs up water. It's kind of a bottleneck in the system. Next slide, please. The area is a mapped FEMA floodplain. It's got detailed mapping on it. The FEMA flood study dates back to the 1970s. At that point in time, the culvert was already in place and much of the infrastructure is already in place. Previously, I believe that culvert and Doyle Drive were built in the 1960s, and there had been a big swamp there that was filled in to create the 2 ball fields. They lost some flood storage back in the 60s. Next slide, please. And we're working with Save the Sound on coming up with the best environmental solutions for the project. Alex, you want to touch
Sure.
base?
Yeah, I can jump in. I'm from Alex Croft from Save the Sound. Jeff also working with us from Save the Sound. We're an environmental organization, but we try to marry ecological benefit with infrastructure. So one of the types of projects that we work on are road stream crossings, also known as bridges and culverts. Turns out that bridges and culverts that are bad for fish and wildlife are also bad for infrastructure. They're too small. Fish and wildlife can't get through them. And also, because they're too small, they often back up or overtop and lead to damage that we see in some of our severe storms. Next slide. We also work on green infrastructure projects. So instead of having just pavement and built landscapes all over the state, we try to reduce the amount of pavement and actually infiltrate rain and other precipitation into the ground so that it goes down into the groundwater instead of just running across the landscape in big runoff floods, and also backing up the storm sewers and things like that, and leading to water quality issues in our natural streams and lakes and ponds. Next. And then another thing we think about when we're thinking about flooding is actually restoring floodplains. So rivers are meant to flood. That's what they do. It's not a constant stream of water. In high water, they get high and they flood onto the banks. So where we can allow that to happen in natural locations, in the woods, along undeveloped stream corridors, we want to allow them to do that. We don't want that happening in people's yards, as we're talking about. We don't want that happening across roadways because that's unsafe and it ruins property, and we don't want that to happen. So if we can restore that and allow that to happen in natural environments, that reduces the occurrence of those floods in other areas along the stream corridor. Next. So when we heard about the problems that were being experienced out on Prindle Ave, we looked around, looked at maps, looked at got onto the site itself, and we came up with some general ideas. We didn't run enough analysis to say whether these would work specifically for this site, but we have enough experience with these types of practices to know that these were some reasonable suggestions. So the first one was to look at actually infiltrating runoff upstream of that wooded area, which is right where your house is. So actually trying to, in the built environment upstream, actually start to infiltrate some of that water from the streetscape instead of sending it through pipes into that wooded area, into the channel, and into your yard. Try to get it into the ground so it is a slow release into the groundwater and into that stream over time, as opposed to big rushing floods. That could be achieved with rain gardens or even grass swales, which is a much simpler maintenance, proposal from a maintenance standpoint. Next. The other thing we noticed when we were out there is in that wooded area, there's some existing stormwater features, including this kind of detention pond on the edge of the ball fields. There's also a wetland out there that seems to be the overflow for that detention pond. We thought maybe that could be the capacity of that stormwater basin could be increased to capture more water and reduce the amount of that's actually getting into that channel during big floods. And then the other thing we noticed was an outfall pipe. So basically the stormwater goes, water goes onto the street, into storm drains, and then out the end of this pipe here. And it comes rushing out in like a high volume of water, high velocities, creates a big scour hole right there. So what that's telling us is that a lot of water is coming out all at once, and that's not what you want. So we thought maybe there was a way to capture that water and have it release more slowly, maybe with some type of constructed wetland at the end of that pipe, or actually reduce the length of that pipe and have more infiltration in the woods so it's getting into the ground, not right into the channel where we don't want it. Next. And then the last idea we had was, going out and looking and seeing that there's about 700, 800 feet of buried stream channel under Nelligan Park. We know that that's going to, Terry's going to talk about how that's actually backing up the water above Prindle Ave and into yards. We thought maybe there would be an opportunity, especially where there's maybe unused portions of that park, to excavate out where that stream is buried in a culvert, remove the culvert and actually restore it to a natural stream channel with floodplains and things like that, so that it can actually expand when it floods and not back up in above Doyle Ave. There's a lot of different ways that a stream can be daylighted. Some are fairly simple, as you see on the top. It's just a pretty natural looking stream going through like a little meadow there. And then there's another example that I have on the bottom, a highly complex example at the Meriden Green, but that's a place where they excavated and daylighted a whole stream channel and created a park with all these different amenities. And that has great flood control benefits. It's a great public park for folks to visit. But same idea and two vastly different examples of how that could be practiced. But those were our ideas, our suggestions to Luke's and to NVCOG. So I'll let Terry take it from here.
Yes, as Alex said, we did our own field investigation. These are photos from when we first went out and looked at the backyard and the surrounding area, and stopped and met. Is it Mrs. Johansson? Miss Johansson? Yes, we were there with the mayor and the public works director at your yard, and you were kind enough, you and your neighbor, to tell us different place elevations that the floodwaters got up to in your property. So when we went out and surveyed, we had people, our survey team shot the elevation of your doorways in your house that were impacted, shot the elevation of the windowsill in your neighbor's shed that the water got up to. And we used that to kind of check how good our analysis was of the existing culvert, see what levels were coming up there in different storms. Next slide, please. Yeah, basically there's the watershed for Whitemare Brook is about 102 acres to Doyle Drive, the head wall that's there. It's about 160 acres total. And the culvert starts at Doyle Drive, but it picks up some watershed going up to Bruns Road, Emmett O'Brien Tech on the west, the main campus, Emmett O'Brien's playing fields on the east, and it goes through that detention basin that Alex was talking about from playing fields. And it all comes together via two channels in your backyard and your neighbor's backyard, and goes to the culvert. The culvert goes underneath Doyle Drive. It's a 48-inch RCP. It then takes a bend, and somehow it gets underneath two baseball fields. We're not quite sure exactly how, because there's buried manhole out there, and Public Works does not have any maps of it, but we surveyed what we could. One of the gentlemen in Public Works said when he was a kid in the 60s, they used to go ice skating back there. So it used to be ponded enough to go ice skating. Next slide, please. So we prepared an existing survey of the work area and used whatever record maps the city had or utility companies had to form a basis of design. We then analyzed the watershed for the hydrology feeding the culvert, compared it to the flows in the FEMA flood insurance study, and they were very close with the watershed area. And we checked it for the latest and greatest rainfalls that are currently in use by the National Oceanic Administration. And actually the total flows that the FEMA study is based on are pretty accurate. So we use those for design. Next slide, please. As I said, the channel upstream of Doyle Drive is constricted. It's constricted in part because people built their homes there. Their sheds are next to the channel. There's the one gentleman built a big retaining wall on his side of the channel, and that pushes water over on adjoining properties. So we try to come up with some ways, as Alex was talking about, use some green infrastructure and see what gave us the best bang for our buck. We did do some research in the upstream areas at Emmett O'Brien Tech, and we think there are some opportunities there for doing something in the future. But the biggest thing that we saw that was creating a constriction was the size of the existing culvert, particularly if it ever gets clogged with debris and brush, which there's an ample supply of upstream. Next slide, please. So we did an analysis and we came up with a design, a series of alternatives, but the one that we are currently showing is a large, replacing the existing 48-inch pipe. As Alex noted, it's 700 feet long. It goes underneath both baseball fields and goes into the swamp downstream, and then drains to Benz Street and Shortell Drive further down the road, downstream. So that culvert barely has capacity to take the 10-year storm. And when you get bigger events like the 50, 25, 100-year storm, that's where you get overtopping the road and water backs up into the upstream properties. So by trying different culvert options, we finally came up with one. It's a 10-foot wide by 4-foot high box culvert that actually drops the water levels down such that they would not impact your house and your neighbor's house and the other neighbor's house. You'd still have water in the stream behind your house down along the back of your backyard, but you wouldn't have water coming up in your house. Now, I don't know about the fact that you've got two streams come together, so you're still going to have some water coming down there. But in our plans, we did it's a 30% design. It's not final design, but we did a idea of what it could look like if we resculpted the channel through your backyard to pull water away from your foundation. And that's what we're showing in our plans right now. It'd still be lawn and maybe some native plantings out there. And possibly the sheds that are right up against the channel could be relocated up on a higher ground, maybe 10, 15 feet away, so they weren't an immediate blockage in the floodway of the channel.
Might it be moved to the other side of the yard?
Yeah, I think there's some possibility there and still allow people to have normal use of their yards.
Move it away from there completely.
Yeah, in an ideal world, it might be appropriate if there wasn't a big retaining wall on the other side of the stream, but we designed it as if that wall is still there.
Just so you know, that wall has fallen down before.
Okay.
And it blocked both.
Well, it would.
It did, and that really, it was, yeah, he had that wall redone.
Yeah. So, oh, thank you. So so anyways, we have a design. It's putting back 700 feet of box culvert. That box culvert will pass not only the 10-year storm, but the 100-year storm, and it has more capacity than the 100-year storm. So it provides for that long-term resiliency that the DEP was asking about in their grant. What happens if we have storms that get bigger or stronger or higher rainfalls? So we've tried to, within reason, make it so it's a robust system that can handle storms even larger than a 100-year storm and protect upstream property. So we've got to review that with the city staff and make sure that we have addressed all the comments, questions they had. There are some options that we didn't do a design for, but we might be able to shorten the length of box culvert if we were able to daylight part of the stream down below the second baseball field. But we'd have to talk with the Ansonia Parks and Recreation Department about that. We can't just go and take away their ball field on them.
Question, that comes from this side of my house. So you're telling me that's still gonna be there, because that water comes over.
Yes, that would still be there, but the culvert downstream of that brook that's backing up water into that brook, the water levels would be lower. So that brook could flow more efficiently, particularly if we regraded it a little bit so it wasn't quite so narrow. And
Well,
we
the
think,
center, it is narrow in two parts, but in the
Yes.
center, it has grown from 1 foot to like 4 feet or more.
yes, you're getting runoff from, as Alex said, from the upstream roads.
So did the impression that you were gonna put a cover through over that.
No, we're not gonna, we're trying not to do that because that creates problems with wetlands laws. The more wetlands you box in, the greater the environmental impact. So what we're trying to do is incorporate some of the green infrastructure that Save the Sound is talking about, maybe reduce some of the runoff upstream coming onto your property, but that would have to be in a final design. It's kind of beyond the scope of some of what we're looking at right now, but that is, we did see some opportunities, and we also saw some opportunities possibly of fixing the detention basin that's Emmett O'Brien Tech's property but that's their detention basin. We would need their buy-in to modify it. We couldn't just go and change it. Yeah, well, I mean, it may be something they'd be interested in, but it's a state of Connecticut school, so you've got to go through a lot of, it took us an amazing amount of time just to get drawings of that detention basin from the state.
This project will widen and make more efficient the channel behind your house. And the culvert itself will drop the backwater effect of an undersized culvert. So you'll see a significant drop in the flood frequency and flood levels. At your property.
And we think we can get it so we'd have to look at the extent of the grading. I just showed it kind of tying in, but maybe we can get it so it's away from your foundation more. So your home itself is not impacted.
Yeah, my foundation is all eroded, it's ruined. I mean, not counting everything else I've lost.
No, I can believe
I
it.
mean, you were there, you
Yeah.
saw, I mean, but you didn't go inside and you didn't see the inside where my living room. It's really bad there. It's just,
No, I can believe it, but we did come up with a design that would lower the water level so they would not get into your sliding door that comes out of your basement and those areas. And keeps the water well away from your house, more so than it is today. But the trouble with a lot of these watersheds is there's been a lot of upstream development. There's a lot of roads, there's a lot of houses upstream of you, and they're all contributing water coming down to you. So it's really trying to grab the water and get it away from your house and lower it, which is what our design has. Next slide, please. Yeah, so this is where I'm saying we're proposing replacing the 48-inch culvert with a 10x4 box culvert, which, as Ron mentioned, would drop the water levels and would the new proposed culvert would be able to pass up to and above the 100-year storm. So it would provide a lot of extra protection for the homeowners. And then and we could relocate sheds and add some native plantings that would be appropriate for a residential yard and provide proper wetland mitigation and habitat. So we think, and as an alternative design, in addition to this, we did look at the idea that maybe some of the area that's on the north end of Nelligan Park, that's out beyond the second baseball field, it had all been filled in. There's a lot of debris in the woods there. There may be an opportunity to save some money by shortening the culvert and daylighting a part of that and actually doing some wetland restoration there. But we would want to talk with city staff on that before we went forward with that, but that would be a recommendation for final design. And that might help the city get funding for this project if there's some grants that are available.
last question about all the trees that are there that are falling, rotten. I mean, they're right on, I cut back the trees, but I can't cut no more because I'm not allowed.
Oh, yeah, for everybody, there's a question about cutting down trees along the stream that are rotten and.
Well, yeah, like along the, going this way from the street, straight across from the wetlands, straight across, I've cut back like 7 trees, but I'm not allowed to cut any further. There's a lot of trees that are falling. They're rotten.
Yeah,
Whose property is that on?
Wetland.
well, it's wetlands, but I think that's either the state or the towns. I don't know. Well, I mean, we could discuss it with the town staff. But
Okay,
city
thank you,
staff.
I appreciate it. Yeah, because one of them fell on my shed and I had to fix the shed, but now the shed is.
Yeah. What's
Were there any other questions about the Ansonia site?
The only one here.
Okay,
This is Jared Heon. I'm on Zoom. Can you hear me?
yes.
yes.
Hi. I'm the emergency management director, and I'm also the chair of planning and zoning. I just wanted to ask a quick question on ongoing maintenance. If that was to go through with the design that you were speaking about with the box culvert, what type of ongoing maintenance is needed, and would easements be required to be obtained from the various property owners in order to maintain that?
The second answer is yes, you would want to have some type of drainage easements. There are drainage easements on some of the old subdivision maps we found. I don't know if they're still active or if they got released at some point. The two things I think the city could do right now is, they could TV the existing 48-inch pipe, see if it's all, nothing's collapsed on it and it's all open. And they might be able to do cleaning on that because it's got accumulated sediment in the downstream end that restricts it even more. Our analysis assumes that all the culverts are clear. When they're not, they could be restricted capacity. The 10x4 box culvert would have much more capacity and require much less maintenance. It would be much less liable to clog with debris and stuff like that on the mouth from the woods upstream. You still could have stuff, but it'd be much more robust and resilient than what you have there today.
The proposed box culvert is a 10x4 rectangle that's a inherently stable, strong structure with a service life of 75 years plus, that generally, other than debris accumulation at the inlets, doesn't require a lot of maintenance. And we factor constructability, duration of construction, and long-term maintenance in our design elements. Alex, you're going to say?
Oh, I was just gonna say, I think the proposed box culvert would be completely on town property, correct?
Yeah.
Yes, there are some properties that abut the edge of the fill on the north end that come right up to it. So I don't know that we need like little easements here and there.
To widen and maintain the channel on the upstream properties would probably require drainage easements, but you're right. The culvert that begins at Doyle Drive is in the Doyle Drive right away, and then the extension of the culvert under Nelligan Field is on city-owned property also. So very little by way of easements or property rights.
Yeah, I agree. I think-
Are you gonna be leveling back my yard the way it was and make the stream more straight instead of crazy?
I think the concept would be move some curves around and move your shed away from the very top of the bank where it's getting hit, and maybe get it to a higher point in your yard.
Like I said, put it on the other side of my yard at the beginning. I don't care.
Thank you. But it's also your neighbor. They have a shed too that's right on top of the bank, and everything constricts the channel. So if we can, the more boost we can make it, the less likely it is to damage your properties. But I do think TVing the existing culvert would be a good maintenance idea, and see if there's any blockages, and then clean it if there's too much accumulated sediment near the outlet. That would be something the city could tackle without spending an arm and a leg.
Thank you.
Yep.
It's just a lot of wood that comes down and just blocks everything, and I'm constantly in there taking everything out.
I just wanted to clarify, you said, so this is just a design phase. We're not going to construction there's no immediate plans for that. So it's not like we're gonna be out there straightening or doing anything.
No, the one I was told next year.
Oh.
That's true.
Yeah, our goal with this study is to have, as Christine said, a full design, some preliminary plans, cost estimates, which the city of Ansonia and NVCOG could then go chase down some funding and proceed in the final design, and then proceed into construction. So I think we've identified all the problems that we see out there, and I think we've come up with some really good practical solutions. It's just a matter of trying to get the funding thing in operation. I believe that's what the mayor had been talking about with that timeline. So if they're interested in it, they want to do it. So
I thought they had told me the money was there.
well, there is for this study, but
They told me that money was there to do the project.
oh, well, they may have some other ideas that I'm unaware of right this
Yeah.
second. Okay.
We want to transition.
Yeah, is that
I think that's all of it for Ansonia. We just want to review all the options with city staff and then finalize everything.
Well, thank you guys for hearing me out.
Oh, no.
Much for joining us.
thanks for
Thank
coming.
Can I see the video again?
I'm gonna,
let's go back there, 'cause they're gonna
start.
start.
So I can get the other slides up. Because I know we. first.
Yeah, it was on the deck.
Yes.
Thanks for your patience, everyone.
Okay. For the Shelton project, thanks for coming out. Both of you were here at the last presentation. As I said, the Shelton covers Oak Avenue and Congress Avenue. There's a series of drainage systems that are interconnected that date back to 1900. There's some very old infrastructure. The city has done multiple repairs on it over the decades. I think the public works superintendent said he thinks 8 or 9 different repairs they've made out there over the years. And anyways, what we did is we took the documentation that Shelton Engineering was nice enough to give us and went and field checked everything and did field survey of the drainage system that's out there today and analyze that to see what types of problems we can confirm and what the possible solutions were. So next slide, please. I'm sure everybody here understands the system, but it starts with a 48-inch corrugated metal pipe that's in a head wall behind 62 Congress Avenue and 60 Congress Avenue. And that collects approximately 110 acres of watershed from Perry Hill Road, Perry Hill School, Sims Way, part of Highland Golf Course, part of Sylvester Way. It all comes down Perry Hill Avenue, dumps into 42 or 48-inch pipe at Sims Way and comes down toward the neighborhood. That culvert has been repaired by Shelton, and when we looked in it, you can see where they had done repairs, and there was still a portion of the roof of that culvert was buckled in 40 feet down below. So it's still damaged. That drains down we think, down the driveway between 2 of the houses on Congress Avenue, comes into a catch basin where it's tied into a small stone box culvert, goes underneath Congress Avenue, goes cross lot down to Oak Avenue, where it goes into a manhole in someone's driveway, and then goes underneath the sidewalk down toward Perry Hill Road. And it has been in different places, a stone box culvert, a 42-inch pipe, a 48-inch pipe, and it ties in with a culvert going underneath Center Street, which is supposed to be a 30-inch reinforced concrete pipe that discharges to the Burying Ground Brook. But when we looked up that pipe is smaller than 30 inches because it's been repaired multiple times with shoving corrugated metal pipe in it and plastic pipe. So there is no portion of this that is a normal size system. You're starting with a big pipe, working your way down the hill where you get more drainage area. You get about 100, like I said, 110 acres by the time you get down to Burying Ground Brook. And you're basically making a huge fire hose shooting in the Burying Ground Brook and probably causing all the catch basin grates to pop and have water bubbling out in a storm as has been reported. Next slide, please. And these are the areas where you've had flooding, and we got really good photographs from the neighbors regarding the flooding at the first public meeting, and that helped us out a real lot, trying to analyze everything and see what we were going to come up with for a solution. Next slide, please. And this is the downstream areas along Oak Avenue, Highland Brook, and it shows the pipe going out into Burying Ground Brook across the street from Perry Hill Road. It's a 30-inch pipe. Next slide, please. And this is some of the upstream areas that are, well, there's a shot there of Bering Ground Brook. It's a narrow confined channel with stone walls on both sides, and people have built their homes and apartments right on top of the stone walls. So it's got a very constricted water course. Upstream, there's little stone flumes on Moore Street that are pitching water down a very steep road that has a lot of flooding issues. There's very little drainage on Moore Street. There's very little drainage on some of the other streets. There's some small pipes, and I've been out there when we've had very torrential rains. I can see where water's puddled up in people's driveways and is causing flooding. Next slide, please. So our game plan in discussing it with the engineering department, public works, is to relocate storm drainage out of private property in the city right away where we can. Try to get it out from underneath sidewalks, particularly these old stone box culverts that keep collapsing when someone drives in the sidewalk. Add additional catch basins and pipes where we can to collect the gutter flow and street flooding problems. And then look at some type of green infrastructure solutions upstream so we can maybe reduce or recommend reduce things that might reduce runoff coming into the neighborhood. Next slide, please. So this is the area that we surveyed. It's actually it looks very white on the screen, but I've got full-size copies here if anybody wants to look at the drawings. We've overlaid it with the town topo and overlays pretty well. There's some areas where things were blocked or whatever, and we're working with engineering to get some catch basins clean so we can get some other measurements on them. But we have a very good picture on the size of the storm drainage. One thing that we did run into is the 48-inch pipe from the head wall that's upstream of Congress Avenue. The city records show it going underneath one of the house foundations, and we don't think it actually does that. We think it actually goes down someone's driveway to Congress Avenue. But that's to be confirmed. There was no TVing of sewers that was allowed as part of this grant. Next slide, please. So these are some of the things that we saw when we were walking around the neighborhood. The connection of the Bering Ground Brook is a very steep 30-inch pipe. As I said, it's not even 30-inch pipe when we looked up. It's had all these repairs to it that are pretty scary when you shine a flashlight up the thing and actually see what it's looking like, barely hanging on there. Makes you want to drive a little faster on Center Street to get over the culvert. But what's happening is the 30-inch pipe is discharging the Bering Ground Brook with so much velocity, it has scoured out the walls, the stone walls on the far side of the brook, and has actually scoured them out on both sides. So there's not a lot left holding up the retaining walls. And there are people's homes and apartments sitting on footings on top of the retaining walls that are holding on for their very life. So we forwarded that information to the city, and we said this is an area where there really should be some immediate repairs to the walls. But this is one problem we saw with very old infrastructure. Next slide, please. And this is, we're out surveying the brook, but then this is, we're up at the 48-inch pipe in the head wall that picks up the runoff from Sims Way. And that photo shows a section of the 48-inch pipe that's leaving downstream from the head wall. It's got a crushed top in it. So structurally, it's got some problems. We didn't see any reason to save that. And we think it goes down the driveway between numbers 60 and 62, I believe, on Sims Way, on Congress Avenue, and goes into the catch basin that's across from, I'm sorry, Mr. Krasheimer? What is it? Mr. Galbowski, I'm sorry. Yeah, it goes into the catch basins near your house, right there. So it's just a bottleneck where it goes into that pipe. And that's probably why you're seeing water shooting up out of the catch basin like 3 feet tall when there's a flood. Next slide, please. And yeah, it's the catch basin that has water shooting out of it. There's a picture of the stone box. And the catch basin top is actually sitting on what looks like an old stone well cap that's broken and ready to fall in any time. And this is a route showing where we think the culvert is actually going through the backyards at 62 and 60 Oak Avenue, but that would have to be confirmed with TVing probably. And next slide, please. And so we have a design in place. We're looking to replace all these pipes with one continuous 4x4 concrete box culvert from the outfall at Burying Ground Brook, where the old 30-inch pipe is now, all the way across Center Street, up Oak Avenue, and then up, I can't read my own handwriting on that, but it's not Union, it's the other street. Oh, Wall Street, I'm sorry, Wall Street, because there seems to be less utilities in the road for it to hit. And then turning up Congress Avenue and then turning and coming into the private properties to go to the head wall. So what this would do is this pipe, this box culvert is sized for the 100-year storm. Some of these pipes are not even sized for the 10-year storm that are there existing. So this would provide a lot more capacity to get water safely through the neighborhood down to Burying Ground Brook. And it would eliminate a lot of the flooding and ponding that was there in Congress Avenue that were shown in the photos that came in. In addition to this, we're working with the engineering department to come up with a design, upgrade the rest of the storm drains in Congress Avenue and Oak Street and Moore Street, so that we're capturing some of the runoff coming down the steep roads and getting those down into these new box culverts that we're proposing. And what that would do is it would eliminate a lot of the street flooding that's impacting people's homes and driveways. So we think we have a very robust design. And next slide, please. So this is just a blow up of the pipe on the downstream end where it's coming out of Burying Ground Brook and then coming up along the road. There are utilities there that we got to work around. There may be some utility relocations that have to occur, but we've got a design that has capacity for the 100-year storm and more. And I've got full-size drawings up here if people want to look at them. So it's actually, we think we have a very good solution that would get water out of your neighborhood and around it. And then as Alex had said, we think there's maybe some opportunities upstream, possibly at the middle school on Perry Hill Road or at Sims Way, to maybe do some infiltration upstream to try and reduce the amount of runoff coming downstream onto your neighborhood and downtown Shelton. Moore Street may be a bit of a challenge because it's got a lot of ledge.
That's for the record, it's Monroe Street.
Monroe Street, I'm sorry.
The last time. That's for anybody listening out there, Monroe.
Thank you. But yes, that was, there's some very interesting spots there and there's a lot of ledge and it's steep and you've got like one catch basin at the very bottom and one flume at the top. And what we're proposing is running a whole trunk line up the hill with catch basins on both sides to peck that up so it's not coming all the way to the bottom and causing flooding at the bottom. And next slide. And this just shows the continuation going up to the head wall. We're, as I said, we're adding the extra pipes now and going to review those with engineering and public works. But we think this is a very strong and robust system. It's just a matter of finding a grant that would fund it for the city of Shelton. And I think that's it. Oh, and yeah, the summary is that we've evaluated the facilities that are going through people's yards and in the city street, and it's a hodgepodge. It really needs to be replaced. It's been band-aided and patched, and I live in town, so I understand why. We have very frugal administration, and there are a lot of needs. But we think this project is a very good candidate for getting state and federal funding if we can find the right grant for it. And we're hoping to work with NVCOG to bring that funding into the community to help resolve these problems. And we may need some easements here and there from some of the neighbors upstream where these ancient pipes go through their backyards, but we think that they're in favor of fixing the problem too. This helps them, helps the city. So that's it. Any questions?
Need the full size copy.
Sure.
I had looked onto your website to see if the proposed options or route goes on there. In these slides that you have, are they going to be posted to the website so we can see?
So maybe I could take that one. So eventually, yes. One thing that I hope was maybe expressed at the beginning of this, that these are still alternatives that each town and city needs to approve. So I think we can certainly post the slides, but I'm not sure about posting full plan sets until the town and city have given their input.
Not even the options.
Well, I think maybe just once we get a sign off from the town. Yeah, thank you so much. That's a great question.
And, but you're welcome to go through the plans with you and stuff like that, so.
See, we have a resident from Sims Way.
Yeah,
Oh.
if there's
Did they
anyone
want to speak?
that would like to share, please feel free to unmute. With a comment or. I see we have a resident from Sims Way. Did you want to comment?
Oh, muted.
Okay, so if anyone wants to comment, please unmute yourself and comment now. We'll give it a couple seconds and then for those in person, you can come up and check out the plans.
And if you can't comment, I mean, you can always call or email too after this.
I'll put my email address in the chat.
Yes. Oh, yeah. Are you John's sister?
Yeah.
Yes, all right. Worked with him for many, many years. So you're probably, yeah, I was gonna say you're over there, but I may not know the right name of the street, but I know I had an M and you were at the intersection.
Started.
That's like a walk access, and so with a hole in the driveway. For no cabin.
Yeah.
So,